Okay, for 32 through 34, we're solving some systems of equations. There's lots of different methods for solving systems. I'm going to just use a couple different ones, but keep in mind that what I'm showing for a given problem here, there's definitely other ways you can do it, so don't feel like the way I'm showing is the way you have to do this one. So for the first one, I'm going to show elimination as an example. And if you remember, for elimination, what we're trying to do is we're going to multiply one of the equations so that when we add them down, one of the variables disappears. If we tried to look here, if we just tried to add these down as we see them, x plus x would give us 2x. That doesn't disappear. 3y minus 2y just gives us y, so the y doesn't disappear. So what I'm going to do is I'm going to multiply this bottom equation by -1 first, and then rewrite the system. I'm picking -1 so that my x's will eliminate. So if I multiply the whole equation by -1, I get negative x now instead of x. Positive 2y equals 1. Now I'm in a position to go ahead and add these equations together to make that x eliminate. So x minus x is going to be 0. 3y plus 2y is 5y. 4 plus 1 is 5. And then I get 5y equals 5. It divides both sides by 5 to get y equals 1. Now I have my y-coordinate of the solution, and I can pick any one of these equations to find x. I'll just go ahead and pick that top one. X plus 3y equals 4. I'm going to substitute y in since I know that y equals 1. X plus 3 equals 4. Subtract 3 from both sides to get x equals 1. So the coordinate of this intersection here will be the coordinate 1, 1. For 33, we're given here that the second equation that x equals y, so to me substitution feels like the most straightforward. So I'm going to do is I'm going to take the first equation, 5x minus 6y equals -4, and since I know x equals y, I'm going to substitute x in for that y value in order to solve it. So 5x minus 6x now, since x equals y equals -4. 5x minus 6x is just negative x equals -4. X then will equal 4. And since we know y equals x, we can also just say that y equals 4. So the coordinate of this solution is 4, 4. I notice I have a problem in the answer key, which says -4, -4. I'll go ahead and quickly correct that, but this is the correct solution to this equation. Yeah, so even if you wanted to, we could validate by putting 4, 4 in to make sure that it's true, but this is definitely correct answer, or you could go ahead and graph these on Desmos and check them that way as well. Last one here, 34, I'm also going to use substitution because this equation is already written in the form y equals, so I can use it relatively easily to substitute. So if I take the second equation, 6x minus y equals 1, I can substitute this equation in for y. So we know that y is -3x plus 2, and then I can simplify here. Remember that negative sign has to distribute. 6x plus 3x minus 2 equals 1. Find the x's to get 9x minus 2 equals 1. Add 2 to both sides to get 9x equals 3. X equals 1/3. And then I have to substitute that back in. To get y, so I'll use this equation here. Y equals -3x plus 2. X is 1/3 plus 2. -3 times 1/3 is -1 plus 2 equals 1. So that's the y value. So the coordinate of the intersection of these two lines is 1/3, 1.